Hello students, today I am going to teach you ninth maths as my name is Ashok sir. Today I will explain number system. First I will explain applications, then theory, and other parts we will explain in the next video. Application means what is the use of numbers in our daily life. Numbers in real life, as it is written here. How many members are in your father's family? There are 4 members in my father's family. Here, 4 is a number as you are seeing in the picture. The next point is how many teachers in your school? There are 26 teachers in my school. Here, 26 is a number. How many rooms in your school? There are 40 rooms in my school. Here 40 is a number. What next? What is the cost of your bag? As you buy bags, then you pay some cost. Then question arises, what is the cost of this bag? Its cost is rupees 700. Here 700 is a number. Next question, how many patients of corona are there in your city? Answer, there may be 50, 250, 400 patients. Here 400, 250 and 50 are numbers as you are seeing in the pictures, coronas. Then the next, how many marks did you score in class 8 mathematics? Answer is I scored 90 marks in mathematics in class 8. Here 90 is a number. Therefore, numbers are very useful in our daily life. Here may be other examples also. Such examples you are seeing in your daily life. So it is called the numbers in real life or use of numbers in our real life. After that, we are going to explain the theory about in these we will tell you about numbers and how many types of numbers in there. Now definitions of numbers, natural numbers, counting numbers are called natural numbers. It is denoted by n as written 1, 2, 3, 4, 5 up to infinite. These are natural numbers. 1 is the least natural number. After that, we will explain about the whole numbers. What are whole numbers? Together with zeros, all natural numbers are called whole numbers. It is denoted by W. Then 0, 1, 2, 3, 4, 5, 6 up to infinite. All are whole numbers. Least whole number is 0 and all whole numbers are not natural numbers as 0 is not a natural number. Okay, after that I will explain the integers. If we write all the numbers as we have defined first and second and use the negative sign also. First we write here a 0. 0 is the letter, it is the initial point. Then right side is positive numbers and left side is and negative numbers. Then this set is called the integers. Or simply we can say whole numbers and negative of natural numbers are integers. As it is written here, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, up to infinite, left side also and right side. These are integers because these are unlimited. After that, we will define the prime numbers. If a number has only two factors, 1 and itself, then number is called the prime number as it is denoted by P 2, 3, 4, 5, 7, 11, 13, 17. and others numbers are also such that called prime numbers. These numbers we are seeing have only two factors. It is divisible by 2 or divisible by 1. Thus we can say if a number have only two factors, 1 and itself, so it is a prime number. If it has other than these two factors, then it is a not prime number. Now we will explain the other numbers, real numbers. Real numbers, all numbers are real numbers except imaginary numbers. Imaginary means which we can only think, but they are not in our real life. So, examples 1, 2, 3, 4, 5, 6, root 3, root 7, minus 1, minus 2, minus 3, minus 4, minus 5, up to infinite. These are the real numbers. Real numbers are two types of numbers, rational numbers and irrational numbers. After that, we will explain the rational number. How we understood which are rational numbers. We are using mostly, or we have studied in lower classes, fractions. If a number is written in the fraction form, simply we can say, and it has not any common factor, then it is a rational number. If, if a number can be written as p by q and q is not equal to 0 and p and q are integers, then number is called rational numbers. As examples 1 by 3, 4 by 7, 22 by 7, 0, 1, 2, etc. These are rational numbers. 0 also are rational numbers because we can write 0 at 0 by 1. It is also rational number. We can write it as 1 by 1. It is 2 by 1. Here q is not equal to 0. So these are rational numbers. After that we will define the irrational numbers. Numbers which are not rational are irrational numbers, are numbers which can't be written as p by q. Numbers are called the irrational numbers, or they are non-terminating numbers also. Non-terminating means which not completely divisible, or we can find the in last digit after dividing. They are continued in division as pi, root 2, root 3, root 5 are 1.232342 345 extra. Here we are seeing it is divided up to here, but it is continued, so it is non-terminating because it is not completely divisible up to here. If we continue, it is going up to infinite. Now we will explain the inserting the rational numbers and irrational numbers. How we insert rational numbers and irrational numbers between the given numbers. Let two numbers are a and b. We want to insert a rational number, then we use this formula. A rational number is a plus b by 2. First we add both numbers and divide it by 2. Then we will find the rational numbers between a and b. If we want to find an irrational number, then it is can be written under root a and b. Or simply we can say we will multiply both numbers and find the square root of these. That will be the irrational number between the numbers a and b. The next method is inserting n rational numbers. Here we are inserting only one irrational and one rational. But if we want to find the more than one, irrational numbers to insert rational number between these two numbers, then we will use this process inserting irrational numbers between a and b. It means first we compare the given numbers. If a is greater than b, then find the difference a minus b, then divided by n plus 1. What is n here? N is number of rational numbers which we are going to inserting. Then we will write it as first a minus b by n plus 1. If we have found out the difference, then we can write these numbers between a and b are where b is smaller. First we add the difference in the smaller number, then b plus d, b plus 2d, b plus 3d, up to b plus nd. This way we can find the n rational numbers between the given numbers a and b. These are three methods inserting the rational numbers and n irrational numbers. Such types of problems we are going to solve. Insert a rational and an irrational number between 2 and 3. First of all, since a rational number between a and b is a plus b by 2, this formula we have explained already. So we will use this one. First we add 2 and 3 and divide by 2. As 2 and 3 equal to 5 divided by 2, it is 5 by 2. Therefore, a rational number between 2 and 3 is 5 by 2, which is greater than 2 and smaller than 3. The next, an irrational number between 2 and 3 is under root 2 into 3. If we multiply 2 into 3, we will get the 6. It is under root 6. Therefore, an irrational number is under root 6. A rational number is 5 by 2 and an irrational number is root 6. Have you understood? If there is problem, you will ask again or you will practice using these formulas as explained here. So if you practice, then it will be easy for you. Now we are going to on the next problem as if we want to find the many rational numbers between the given rational numbers, as find 5 rational numbers between 3 by 4 and 4 by 5. Here 5 is given, it means n equal to 5. First we find n plus 1, it is 6. 5 plus 1 equal to 6. Then we compare the numbers. 4 by 5 is greater than 3 by 5. Here a smaller number is 3 by 5. Then we find the difference and using by the formula as it is written here, a minus b by n plus 1. Then d is 4 by 5 minus 3 by 5 by 6. Then one difference of 4 by 5 and 3 by 5 is 1 by 5 and 6 as written in the denominator, it will be 1 by 30. 5 6 ja 30. Rational numbers are in the formula we have written already in the theory as b plus d, b plus 2d, b plus 3d, b plus 4d and so on. So first we find the first five rational numbers between these two numbers. Then first we write the smaller number in both as we have compared already 3 by 5 and add the difference, and after then we take the LCM and solve it. We will find then 5 5 5 6 ja 30, then 6 3 ja 18, 18 and 1 19, then 19 by 30. Same way we will find the next rational numbers. 3 by 5 plus 2 by 30, 5 6 ja 30, 3 6 ja 18, 18 and 2, 20, 20 by 30, or we can write it also 2 by 3 also as you write, and this way also. Similarly, we can find the other numbers as third is, here we are seeing we are adding 1, then 2, then 3, then 4, then 5 in the 18. Then it will be 21 by 30, 22 by 30, 23 by 30. This way we can find the five rational numbers between 3 by 4 and 4 by 5. As they are written here, 19 by 30 as we have found it here, then 20 by 30 it is finding here, then next 21 by 30, 22 by 30 and 23 by 30. Then it is very simple if we practice it and then think about the theory and formula. So we will solve such types of other sums. If you find any problem or difficulty, then I will help you again. The terminating decimal numbers are, terminating means after some digits it is completely divisible. Non-terminating, after some digits it is not divisible. It is continued up to infinite. These are non-terminating. Terminating decimal, if number is written in the form p by q and q is equal to 2 raised to the power m, 5 raised to the power n, then number is terminating where m and n may be equal or different. Equal may be also and different also. Sometimes these may be zero also. And examples are 7 by 25, 18 by 75, 725 by 625. Add extra. Then next, non-terminating numbers. If numbers have factors in denominator other than 2 and 5, then number is non-terminating decimal number. Examples 1 by 3, 1 by 7, 5 by 14, 36 by 49. The such we can write up to infinite also because they are unlimited. Then next, non-terminating recurring decimal numbers. Recurring means if a digit or group of digits are repeated, then it is recurring. A decimal number in which a digit or group of digits repeated periodically in is called the repeating or recurring decimal number. As we have divided 1 by 3 many times in lower classes also, but not we don't know it is recurring or recurring. But in this class, when we write this way and divide it, we are getting a 0.33333 up to infinite. We can write this number as 1 by 3 equal to 3 and bar. We read it 3 bar and 3 by 11 equal to 0.272727 up to infinite. Then it is 3 by 11 27 bar. Bar means it is continued or repeated. 3 by 13 equal to 0.230769. Then after these group of digits it will repeat it. Then 3 by 13 equal to 0.230769 bar. Numbers of digits in this group are 6. The length of its period is 6. Now this way we can find the length of group also or period also. Here period is of 6, here 2, here 1. Now we are going to explain the representation of rational numbers on number line. We have drawn many times number line as numbers on the line. First we decide the origin point, then we mark it at equal distance here as it is presented here. The left side positive and right side negative here, and distance should be equal. It is 1 by 2, 2 by 3 by 2, 4 by 2, 5 by 2, 6 by 2, and 7 by 2 by 2, as it is written here. It is this way. It is a necessary compulsory that the distance should be equal left and right both sides, and first we decide the origin point. As problem is this, represent minus 1 and 5 by 7 and 2 and 3 by 7 on number lines. As we have drawn a line with the help of the scale and decided that then mark the origin point, then right side 1, 2, 3, and left side minus 1, minus 2, minus 3. And first number is greater than 1. So first we will take, but it is negative. So we will mark it to the left side. It is minus 1. After that we need 5 by 7. Then first we divide the distance between 2 and minus 1 and minus 2 in 7 parts and take 5 parts. 1, 2, 3, 4, 5. So it is our point p equal to minus 1 and 5 by 7. Same way, it is written 2 and 3 by 7. So first we take the 2, then the next point between 2 and 3, it will be because it is greater than 2. So we will divide, here denominator is 7. So we will divide it in 7 parts, equal parts, and take 3. 1, 2, 3. It is our point on number line. We have marked here as in the problem it is given. This way we can show the rational numbers on number line. These are real numbers also we have. Then next, these are some important rules for exponent. As you know already, if you don't know, you can see here and try to practice on this. Then a raised to the power m into a raised to the power m. Here base is same, so we can add these two powers a raised to the power m plus 1. If we going to divide and base is same, here a raised to the power m, a raised to the power m. So we can write a raised to the power m minus 1. In multiplication, we add the powers. In division, we subtract the powers. Here, in denominator, it is n, so we will subtract n. Here, a raised to the power n multiplied by n, because it is also power, it is also power. So we will multiply the powers in these types of problem. Now, on the next, a raised to the power m and b raised to the power n. Here power is same and this is different, so we can write it. We can take power as common, a into b raised to the power. Here it is written if such types of a into b raised to the power m, then we can write this separately. A raised to the power m into then a b raised to the power m equal to a raised to the power m into b raised to the power m. A by m raised to the power m equal to a raised to the power m by b raised to the power m. A raised to the power minus m because power is negative, so we can write it as a by a raised to the power m. And then the next, if it is written this way, a raised to the power 0, then its value always be 1. It means we can say if base may be anyone, if power is 0, then its value is 1. Then next, n under root a equal to 1 by n. These are formulas, these are very useful, so you should learn or practice. Then x equal to n under root a raised to the power m equal to a raised to the power m by n. So these are very important formulas, so you will learn and practice and simplify such types of problems as these are given here. Simplify the following expressions as 3 raised to the power 3 by 4 into 1 by 4. Here we are seeing base is same, so we will get the powers as we have studied already here. And we know since a raised to the power m into a raised to the power m equal to a raised to the power m plus n. As we have added, then we take the LCM and find the sum, and it will be 3 raised to the power 3 plus 1 by 4, then 4 by 4, 3, then 4 by 4 we can write 4 1 the 4 equal to 3 raised to the power 1 equal to 3. Here, solution after solving we get the answer. Its value is 3. Now we going to next. It is product. It is division sum. We will explain all types of sum here. Right. Then 5 raised to the power 1 by 3. 5 raised to the power 1 by 6. It is in division. So we will find the difference of powers here because base is same. 5 raised to the power 1 by 3 minus 1 by 6. We will get here 5 raised to the power 2 minus 1 by 6, and it will be 5 raised to the power 1 by 6 equal to 1 by 6. If you know the solving the fractions, and it is we taken here LCM is 6, 3 2 the 6, 2 1 the 2, and 6 1 the 6, 1 into 1, and we are getting here 1. Then find the difference. It is 2 minus 1 equal to 1 by 6. Such types of questions it is. So value is 5 raised to the power 1 by 6. Answer is 5 raised to the power 1 by 6. Now we are going to solve the next problem as 16 raised to the power 3 by 2. Such types of questions, if it is possible, so factorize the given number as we have factorized here. 16 can be written here 2 into 2 into 2 into 2. Then we will, as we have written here, but it is repeated here, then we can write here 2, 2 raised to the power 6, and it is multiplied. Here we have first problem is this, so we have written here 2 raised to the power 4 into 3 by 2, and 4 is cancelled, 2 to the 4 and 2 3 the 6. So it means after multiplying, we have got here it is 62. Now we are going to divide the first to the second by it is division sign. So we can write this way. It is 4 under root 81 x raised to the power 8 y raised to the power 4 is z raised to the power 16 divided by 3 under root 3 under root 3 under root 27 x raised to the power 3 y raised to the power 6 and z raised to the power 9, and we are going to solve it in as because it is the we want to divide this one by this, so we will write in denominator this one and it is in numerator, and same first we copied it. 4 under root 81 x raised to the power 8 y raised to the power 4 z raised to the power 16 by under root 3 and by 3 under root 27 x raised to the power 3 y raised to the power 6 z raised to the power 9 equal to this one. Here we are saying here powers are, here it is 4 8 4 16, so we can take here because it is written here under root 4 4 under root, so we can write this way 1 by 4 and 1 by 3. Then we have take factorized this number 81 3 raised to the power 4 27 3 raised to the power 3 and taken the power here 4 1 by 4 4 4 is cancelled 4 3 3 is cancelled, so it is in typing problem is here, so we can take common 4 but it is divisible by 4 also. Then 4 1 ja 4 4 1 ja 4 4 2 ja 8 4 1 ja 4 4 4 ja 16, so it is written here 3 into x square into y into z raised to the power 4 and 3 into x into y raised to the power 2 into z raised to the power, and after that if it is possible to cancel the number then we will cancel 3 1 the 3 and solve the powers if base is same. X here power is 2 here 1, so it is in denominator 1, so we can write it x raised to the power 2 minus 1, here z raised to the power 4 and 2, so we can write z raised to the power 4 minus 2 and y here is 1 here is 2, then in denominator its power is greater, then y raised to the power 2 minus 1, here x raised to the power 1 z raised to the power 2 by 1. 1 we never write here in the past, so we can write it x z square by y. It is answer x z square by y. Now we are going to explain the other problems such types of, as this is very important problem and this is mostly comes in exams also, and it is written here simplify x raised to the power l by x raised to the power m and bracket closed, r is 1 by lm, and same way it is written x raised to the power m x raised to the power n whole to the power 1 by mn x raised to the power n x raised to the power l 1 by nl. Here we are seeing base is same, so we can subtract the powers in this also and in this also. Then x raised to the power l minus m, because whole power is 1 by lm, so we have written here x raised to the power m minus n whole raised to the power 1 by mn x raised to the power m minus l, it is written here 1 by nl, and x we will multiply this power to these two. If it is multiplied by L, then LL cancel. Here will remain only 1 by N. Same way 1 by L, same way 1 by N. If we multiply this to this and 1 by N. And x raised to the power 1 by L minus 1 by N. Because we are seeing here base is same. Here is x, here is x, here is x also. Then we take the powers and add these all. X In the bracket we have written here 1 by m, 1 by m minus 1 by l plus 1 by m minus 1 by m plus 1 by l minus 1 by m. M here it is positive, here negative. It may be it is cancelled. 1 by L minus 1 by L positive cancelled. 1 by N and positive, 1 by N negative, it is cancelled. Thus we are getting x raised to the power 0 because everyone is cancelled. Then we know as already a raised to the power 0 equal to 1. So x raised to the power 1 0 equal to 1. Answer is 1. It is not difficult as first we have subtracted the powers, then multiply by the powers and getting this way 1 by m and minus 1 by L. Then we have added all these powers because it is product. This multiply by this and this and this. So we will add the powers if base is same. Here we are saying base is also same. So we will add these powers. After adding we have got here x raised to the power 0, so its value is 1. As we know, if any base has power 0, its value will be 0. Now we will go into the next as successive magnification for recurring, and it is written here bar, so it is a recurring number. And how we show on number lines, so we can write this problem such way also. Visualize the representation of 2.32 bar on the number line up to 4 decimal places. How many places? 4 decimal places. So first we see what be its value. Its value be greater than 2 but smaller than 3 because it is 2.32. First we mark the numbers on number lines, and first we decide the origin point, then left and then right. Lefts are negative, rights are positive. So these are 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3. Because its value is between 2 and 3, so we have selected these two numbers 2 and 3, then divide this value in the 10 equal points because it is decimal. So always if we divide the distance between the numbers in 10 equal parts. As we have written 2.1, we have explained it, exceeded it, or we can say increase its distance to visualize. We want to visualize, it means we want to write on the number line in real positions. 2.1, 2.2, 2.3, and 2.4, 2.5, 2.6, 2.7, 2.8, 2.9 up to 3. Now we are seeing it is 2.3 and 2.4. Its value is between 2, more than 2 and less than 3. So, and we are seeing it now here it is greater than 2.3 and smaller than 2.4. So we have taken these 2 points and again divide its distance it into 10 equal parts at 2.3, 2.31, 2.32, 2.33, 2.34 and so on. After that we will take, because value of this be 2.32 between and 2.33. So we will take this distance and again divide in 10 equal parts as we have written 2.32, 2.321, 2.322, 2.323 and 2.324 and so on we have divided. Now we are seeing here its value is between 2.322 and 2.323. Now we will take this distance and again divide in 10 equal parts. Then we will divide it 10 equal parts and we write this 2.322, 2.322, 1, 2.3222, 2.3223, and 2.3224, 2.3225, 2.3326, and so on. We have as we have written here. So it is written 2.32 bar, 2.32 bar, 2.32 bar. We have divided in it is greater than this one and smaller than this one. This way we can see these numbers on number lines. Now next, as number is terminating, so we can see so on number line this way. Locate 3.895 on number line. As first we decide the origin point and they divide the distance in equal parts, and its value is greater than 3 and smaller than 4. So we will mark 3 and 4 and then expand this distance and divide in 10 equal parts as we have written 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, and so on. As it is written here, a 3.8 and 3.9. Then its value is greater than 3.8 and smaller than 3.9. So we will take this distance and extend it and divide in 10 equal parts. And same way we have written here 3.8, 3.81, 82, 83, and 8, 3.89 and 3.9. We will take because its value is greater than 3.89 and smaller than 3.8, 3.9. Then take this value and this length and extend it. Then again we will divide into 10 equal parts, and this way we can write it is written here 3.89, 891, 892, 893, 8, 894, 895. So it is its value on the number line 3.895. So this way we can write the numbers, or we can say so on numbers on the number line. Now if numbers are terminating, then we will show on number lines by this method. Now next, rationalization. How we rationalize the number? Let me. If a number has irrational denominator, then process of converting into equivalent number where denominator is rational number by multiplying its numerator and denominator by suitable number is called rationalization. Rationalization means there should be not a sign of root in the denominator, but we multiply denominator and numerator both by the same value. Why? Because we want to solve the problem but not want to change the value of the problem. It is compulsory. We will multiply both by the same number. Then, as it is written here, as example is rationalize 4 by under root 7. As we are going to solve it, 4 by under root 7 multiplied by under root 7 into under root 7 and we are going to multiply numerator and denominator of the number by root 7 because value is same, so it is unchanged, and if we multiply then we will get it 4 into root 7 equal to 4 root 7, and root 7 into root 7 equal to root 7 square, then square root cancel with the square, so 4 root 7 by 7. Here is not any any square root sign, and both are both value is same as it is given. It is called the rationalizing method. The number with rationalized denominator is 4 under root 7 by 7. Answer is 4 under root 7 by 7. The rationalized factor. If the product of two numbers is rational, then each one is called the rationalizing factor. As written here, rationalize under root 5 plus under root 3. Solution is under root 5 plus under root 7 into under root 5 minus under root 3. Because we know here it is a plus b, it is a minus b. As we know, a plus b, a minus b equal to a square minus b. The square of under root 5 is 5, square of under root 3 is 3, then 5 minus 3 equal to 2 is a rational number. Then, therefore, under root 5 plus under root 3 and under root 5 minus under root 3 are the rationalizing factors of the given number. Such way, if you have any problem, then you can solve this way and use this identity. If there is any problem, you can ask again. Now, representation of root x on number line. Root x means as under root 2, under root 3, under root 4, under root 5, under root 7. These values how we represent on number line. So problem is this: find the value of under root x geometrically. Then we can get a b. See here a and b. A b equal to x unit and BC equal to 1 unit. 1 unit means it may be 1 centimeter or 1 inch also, but we have taken here 1 centimeter as, so AB equal to x unit, BC equal to 1 unit. Therefore, AC equal to x plus 1. A and C, 1 unit. X plus 1 unit. Now we will divide it. We want to find the OC. Here, AC is the diameter of semicircle and OC is the radius. Because we know the radius is half of the diameter. So we have divided it x plus 1 by 2. So OC is the radius, it is x plus 1 by 2. OC equal to OD. We are saying here OC is center to circumference and OD is also center to circumference. So both are radius of the same circle. So OB equal to x plus 1 by 2 OD. OB. We are saying here OC is x plus 1 by 2 and BC is 1, but we want to find the OB. So we will subtract here OC minus BC or OC minus 1. OC is x plus 1 by 2 and BC is 1. We have subtracted here, take LCM, and we have got here OB equal to x minus 1 by 2. Now in the right angle triangle OBD, angle B is right here and OD is hypotenuse and OB is base and BD is perpendicular. With the help of Pythagoras theorem, 2d square equal to 2b square plus bd square. But we want to know the value of bd. bd. It is perpendicular, so we will transpose 2d square minus 2b square and it will be bd square. Therefore, bd square equal to od square minus ob square. We have found it already. Od and ob. Od is this one and ob is this one. So we will put here value od equal to x plus 1 by 2 minus x minus 1 by 2 whole square. Now we are seeing here it is in the form of a square minus b square. So we can write a plus b and a minus b. After taking LCM, so we can solve LCM will be 2. So x plus 2 plus x minus 1. 1 is cancelled here. Here also LCM is 2 and x plus 1 minus x plus 1 because here it is negative. When we use the negative sign, then we will change the sign of the next bracket or next value. So we have changed the sign also. X is cancelled. Here will be x plus x, 2x and 1 plus 1, 2. 2x by 2 and 2 by 2. 2 1 the 2 and 2 1 the 2. Here will remain only x. It is value of bd square. Since bd square equal to x, therefore bd equal to under root of x. Thus we have found the value of under root x geometrically and it is bd. bd. bd we have found it, but bd is not on the number line. But my purpose is to present body on the line. So we will take the distance, radius, BD and BS center then or thus BE, BE equal to under root x, which is the value of under root x and on the number line also. Have you understood? So we will work it again and practice it. And now we will solve such types of problems as we had told you already. With the help of example, I will explain it again. Representation of under root 2, under root 3, under root 4 on the number line as representation of numbers on the number line. It is written here. With the help of this, working is same as we have done in the done already, but we want to represent these values. So same way, let x OX be the horizontal line. OX be the horizontal line as x-axis the x-axis and but add the x-axis and let O be the origin. If O is origin, it is x-axis, x and x base. Then take OB equal to 1, OB equal to 1 in it, and BC, BC equal to also 1 in it. Unit. Unit means it may be different also. Centimeter, centimeter, inch or inch, but both be same. Same unit may be different. Then join AC. Now with the help of Pythagoras theorem, OC is the hypotenuse. We will find the OC equal to under root OB square plus BC square, 1 square plus 1 square under root 2 units. With O as center and OC as radius, draw an arc meeting OX at P. OX at P. In OX at P. Which is under root OC is under root 2. Again, if we want to present the under root 3, then we draw perpendicular at point C, but its distance should be the 1 unit. And because it is the under root 2, it is 1 unit. We have joined OC here. So if we calculate the OD with the help of Pythagoras theorem, then we will get here. Then we will get here the same value as OP is represented by under root 2 on the real line. Now draw CD perpendicular to OC such that CD equal to 1, CD equal to 1 in its joint OD. Now we have calculated here OD equal to under root OC square, OC square plus CD square. OC is under root 2 and CD is 1. Here we are saying CD is 1 and OC is under root 2. Then after squaring and adding, then we will get square of under root 2 is 2. It is square of 1. Then we will get here under root 3 units. With OS center and OC as radius, OC as radius, draw an arc meeting OX at Q. Then OQ and OD equal to under root 3 OD. Are you seeing O to Q? It is equal to O to Q. It is O to D. This arc is coming here. Now next, now draw DE perpendicular to OD. DE perpendicular to OD, and it is D equal to 1 unit. Now join OE. Then OE equal to under root OD square plus DE square equal to under root 3 square plus 1. It is square of under root 3 is 3. 3 plus 1 equal to 4. The square root of 4 is 2 unit. Thus, OR represents this way under root 4 equal to 2 on the real line. Thus, we can represent these numbers on the real line also. Such types may be other sums also. Now, we are going to explain the other sums, solve sums, class tests, and assignment on the next video. But now till now, you will see these numbers, and after that, you will get the solution of these problems and next video. Thanks all of